Howdy y'all, today we're going to be doing double angle formulas. And like last week, this is just more formulas on your chart. On the second page, which I believe I gave you already, you're going to see these three equations at the top of the sheet. And we get sine of 2x is equal to 2 sine x cosine 2x is equal to cosine squared x minus sine squared x, which is also equal to 1 minus 2 sine squared x, which is also equal to 2 cosine squared x minus 1. And then lastly, we have the tangent of 2x is equal to 2 tangent x divided by 1 minus tangent squared x. Now, I want to call your attention to the cosine of 2x formula. You're going to notice that we have three different formulas to use, and we'll be using all three hopefully today. Another thing to call attention to is the fact that this is 2x, which means that the sine of 2x is going to be twice as big as the angle of sine x and cosine x on the other side. And if we were careful, we would have noticed that I had miswritten that as the cosine of x on that side. Okay, so let me get started. Find the exact value of sine 2x, cosine 2x, and tangent of 2x given the following conditions. Number 1, sine of x is equal to 3 over 4, and we are given a stipulation on our domain. Pi over 2 is less than x, which is less than pi. So why don't we go ahead and start by drawing our nifty little triangle. Now, pi over 2 is 90 degrees, and pi is 180. So I know that my triangle is going to be in the second quadrant, or over here. So I'm going to go ahead and draw my triangle, and sine is opposite over hypotenuse. And if I know my Pythagorean identity, I can figure out that this is the negative square root of 7 down here on the x-axis. Okay, so now that I have that, why don't we dive into finding what the sine of 2x is. So I have the sine of 2x, which is this degree measure right here, and the sine of 2x, according to our formula, is 2 sine x times cosine x. Well, lucky for us, they gave us what the sine of x was. So this is 2 times 3 over 4. And notice I replaced that sine x with 3 over 4. And then cosine, which we can figure out is adjacent over hypotenuse. So negative root 7 over 4. And when I multiply all this out, I am going to get negative 3 root 7 over 8. That would be the sine. Now the cosine of 2x, I can use both formulas. Now guys, remember how I said that this from, where's my little pen? There it is. From here to here, so from my positive x-axis to my bar is x, I'm finding where 2x is. So it's going to be somewhere down here below the x-axis. So I'm going to, for this one, why don't we use the cosine squared x minus the sine squared x. And I'm hopefully not run out of room. Drag that over a little bit. Okay. Well, I know that the cosine of x was negative 7, or negative root 7 over 4. So I'll square that. And when we square a fraction, we square both the numerator and the denominator. And we'll subtract that from 3 over 4 squared. So that gives us 7 over 16 minus 9 over 16, which will come out to negative 1 over 8. Okay, and then lastly, we have the tangent of 2x. Now, since I've already taken enough time to solve for the sine of 2x and the cosine of 2x, I can realize that the tangent of 2x is just going to be the sine of 2x divided by the cosine of 2x. And when I divide fractions, I take the bottom one and I flip it over. I take the reciprocal, that's called, and I multiply. So I multiply by the reciprocal of the denominator, and I end up getting 3 root 7. That would be the sine of 2x, the cosine of 2x, and the tangent of 2x, given what the sine of normal x is. So why don't we move down to number 2? Number 2, they told me that the cotangent of x is from negative 3 over 2, and we go from 3 pi over 2 to 2 pi. So I'm going to go ahead and show you where that is. It'll be from 3 pi halves is down here at 270 to 2 pi, which is a full 360. So we're in quadrant 4 now. So we'll go ahead and draw a triangle, and we know that the cotangent, which is 1 over tangent, and tangent is opposite over adjacent. So cotangent would be adjacent over opposite, and that's a cotangent. So adjacent being negative, or adjacent being 3, and opposite being negative 2. And I can figure out using my Pythagorean triples what this side length is. And I'm going to go ahead and stop here, and I'm going to let you guys do this one on your own. And remember, I want to see what the sine of 2x is, what the cosine of 2x is, and what the tangent of 2x is. And for the cosine, I'm going to let you choose which of these 3 formulas you want to use. But I'd recommend using something other than cosine squared minus sine squared, just because I used that at the beginning. Okay, as so this video won't be 30 minutes long, why don't we go ahead and move on to number 3. For each of the following, we're going to find the general solution and a particular values from 0 to 2 pi, or 0 to 360 of these guys. Now, what I'm going to be doing is I'm taking these equations and I'm going to try and make it look like one of these guys. So I noticed that 4 sine x cosine x looks a whole lot like 2 sine x cosine x. So what I'm going to do is I'm going to divide both sides by 2. So after dividing both sides by 2, I get 2 sine x cosine x is equal to 1. And this guy over here on our left is equal to the sine of 2x, which is equal to 1. And once I take the arcsine of both sides, I get that 2x is equal to pi over 2 plus 2 pi n, and 2x is also equal to negative pi over 2 plus 2 pi n. And we're going to notice that these are the same thing, and once I divide everything by 2, I get x is equal to pi over 4 plus pi n. And this would be our general solution. And guys, just so we remember, I got this solution from taking the arcsine, this guy, of 1. That's what that was. So now for part B, I need a list of values in between 0 and 2 pi, or 0 and 360. So my first one, when n is equal to 0, will be pi over 4. And then my second one will be 5 pi over 4, because pi plus pi over 4 is the same as 4 pi over 4 plus pi over 4, which is pi plus 4 pi is 5 pi. That's a mouthful. And then the next one will be outside of our range, because that will be 9 pi over 4, which is greater than 8 pi over 4. So 9 pi over 4 is not in our specified values. Okay, now for number 4, we have 2 cosine squared x minus 1 is equal to the negative root 2 over 2. Now, I'm going to call to your attention, like I've done before in class, and they rationalize this denominator. And I and Mr. G will agree that we don't like rationalized denominators. So I'm going to go ahead and unrationalize it. That'd be negative 1 over root 2. So 2 cosine squared x minus 1 is equal to negative 1 over root 2. And I'm going to notice that this looks a whole lot like the cosine of 2x, that third formula. So the cosine of 2x is equal to, where'd my little marker go? Oh, here, right? The cosine of 2x is equal to negative 1 over root 2. Now, on your guys' own, I want you to find out what the general solution to this problem was. And remember, we're going to take the arc cosine of negative 1 over root 2. So I want to know whose angles will give me a cosine of negative 1 over root 2. Okay, last two problems, I promise. Okay, the double angles properties work whenever one of the arguments is twice as large as the other. For example, sine of 14x can be written as sine of x and cosine of x, or the sine of 2x. So we're basically going backwards now. So I'm going to rewrite the tangent of 26 as the tangent of 2 times 13 of x. And there goes that printer. Okay. And we know that for our double angle formula for tangent is equal to 2 tangent of 13x all over 1 minus tangent squared of 13x. And lastly, we have cosine of 10x, and they want it in terms of sine x. So they're forcing our hand into using the cosine of 2x is equal to 1 minus the sine squared of x. So we need to rewrite the cosine of 10x in terms of pull out a 2, so we get the cosine of 2 times 5x is equal to 1 minus sine squared of 5x. And guys, that is all for today, and I will see you tomorrow in class. Goodbye.